Okay, welcome back to the System of Equations notes. This is page 6. We are going to back up to page 5 here just a minute and talk about the steps when we solve a system of equation with 3 variables. First thing we're going to do is eliminate a variable from any 2 equations. Okay. Then we're going to eliminate the same variable from a different pair of equations. We're going to eliminate a second variable using the 2 equations we've just created. That way we can make an equation with just 1 variable. We're going to solve for that 1 variable and find the values of the remaining variables by substitution. We're going to write the system of the solution as an ordered triple. So x, y, z. Let's take a look at how this works. I am going to start by just adding these 2 together, and I'm going to go ahead and move it over here. When I combine, I get 3x plus 2y. My z's go away. That equals 4. So when I choose 2 different equations, I want to eliminate the z. So I'm going to choose these 2 because the z in my second one is negative. I got 3x plus 9y plus 6z equals 3. I'm going to multiply this equation by 6. So I get 12x plus 6y minus 6z equals 12. When I add them together, I get 15x plus 15y equals 15. Now, if I wanted to, I could divide everything by 15. And get x plus y equals 1. I can use elimination or substitution here, but let's do this. I got 3 times 1 minus y plus 2y equals 4. 3 minus 3y plus 2y equals 4. I get negative 1y, subtract 3 from both sides equals 1. So y equals negative 1. There's my first variable, and it doesn't really matter what order we solve these in. But I am going to go back up here, because now I got x equals 1 minus, my y is negative 1. I got x equals 2. And then I'm going to pick an equation to plug it in. I'm going to make it easy on myself and pick this one. I got x is 2 plus y is negative 1 plus z is 2. 2 plus negative 1 is 1 plus z is 2. Subtract 1 from both sides and z is 1. My ordered triple has to go x, y, z. And then we can always plug it in to another equation just to be sure. So let's go ahead and plug it into the top one. I got 3 times 2 plus 9 times negative 1 plus 6 times 1, and that is supposed to equal 3. So I'm going to check. I got 6 minus 9 plus 6 is 12 minus 9, which is 3, so it works there. So I've done that and checked it again. The ordered triple, again in order, x, y, and z. Okay. Example 7, we are going to solve a system where we only have 2 equations. Now here's the thing. I need as many equations as I have variables if I want to get this down to numbers. But here's what we're going to do here. I'm going to go ahead and multiply the top equation by 4. I got 4x plus 8y plus 4z equals 16. My other equation is 3x minus y minus 4z equals negative 9, and I'm going to add these together. 7x plus 7y equals 7. Again, I can divide everything by 7. I get x plus y equals 1. So what I'm going to do is I am going to solve. How do we want to do this? Solve for x in terms of y. That works. I am going to go ahead and come back up to this top equation again. And in my equation, I'm going to substitute in what I just solved for. So this is the equation I'm using, x plus 2y plus z equals 4. My x is 1 minus y, so I'm substituting that in. That's what I've decided or solved for. So I've got 1 minus y plus 2y is plus y, plus z is 4, y plus z, subtract the 1 from both sides, and I get 3. And again, I'm going to solve in terms of y. Z is 3 minus y. My solution here, my ordered triple, x in terms of y is 1 minus y. Y is whatever I substitute in, and my z in terms of y is 3 minus y. So we have solved for the ordered triple. We're going to start by picking a y value, and we'll use that to solve for x and z.